Hey everyone, and welcome to the 9th video of the Let's Start with Jitter series. Today we're going to talk about the anim system. So the anim system, as the name suggests, allows us to animate position, scaling and rotation of 3D objects in our virtual world. So we got 3 objects to do that. We got jit.anim.node, jit.anim.drive and jit.anim.path. Now, in this video, we are just going to see anim.node and anim.drive, because anim.path is a bit more convoluted. It will require us a bit more time to look into it. So for the moment, we are going with anim.node and anim.drive. So in order to see them at work, let's create our jit world so we can have some rendering in our window. And I will call it my world. And let's give it floating 1. Let's give it just a default size. For the window, let's give it full scale anti-aliasing. These are all attributes that we saw in the previous videos, so if you don't remember what they do, go check out the previous videos or check out the help file of jit world. And then let's give it an erase color of, I don't know, something random really. And let's see which color we get like this. And let's also enable it by default. And there we go. Nice blue. Nice. Let's also create a jit.fps GUI to check our frame rate, see that stuff is happening. Now, as we saw in the previous videos, we can create a GGL grid shape and have it render it on the window, right? And let's assign it a GGL PBR to shade it, so to set its appearance. And let's maybe set the matte diffuse of PBR to something nice, like red. And this looks pretty nice. And this sphere is definitely too big, right? It's covering the whole window. So if we want to see less of this sphere, as we already saw, we can set its position a bit farther away on the z-axis. So 0, 0, -4 or something, right? The minus axis, the minus z-axis goes away from us. Now we can modify the position, scale, and rotation of the sphere. These are the transformations. These in geometry, I guess, are called the transformations. So we can apply these 3 transformations to the sphere, either like we just did, using the attributes here, like position. On the GGL grid shape, we could say scale, 0.2. Then we could say rotate, XYZ, like whatever. We don't really rotate because it's just a sphere, so let's maybe give it a shape cube. And let's rotate it 45 degrees on the x-axis, right? Scale it a bit bigger. Right. So we can apply these transformations either on the GGL grid shape object itself, or we can use a jit.anim node for that. So let's create a jit.anim node. Let's connect it to the GGL grid shape. And what happens when we do that is that all the transformations that we applied to the grid shape are overridden. They don't do anything anymore, right? So we can just delete them, nothing will change. Now, if we want to change position, scale, and rotation, we need to set those on the anim node. So, for example, we can set position, 0, 0, minus sphere, and we can say rotate x, y, z, 45, 45, 0, something like that. What have I written? Right. So when we connect a jit.anim node to a GGL grid shape, we are overriding all the transformations attributes of the grid shape. So you're probably asking yourself, okay, but what does this bring us? What is the advantage of using anim node instead of using just GGL grid shape attributes? And the answer is that with anim node, we can have hierarchical transformations. Is this how you write it? Transformations. And I wrote it wrong. This is with I, not with Y. So hierarchical transformations with jit.anim node. What does this mean? That if we could have another anim node, and let's do this. Let's scale this 0.2 on the, let's scale it 0.5, 0.2, 0.2. So it's like an elongated cube, a parallelepiped. And let's not rotate it at all, and let's not position it also at all. Let's just scale it, right? And let's get this anim node and connect it to this anim node. And now, what we are doing, we are setting the position of this anim node from the parent anim node. So this is the parent, and that's the child. And everything that we do to the parent is going to be reflected to the child, but the child on top has its own parameters. So if we scale, for example, this by 2, the child is still going to apply its own scale to the grid shape. So the cool thing is that we could have another grid shape here with another anim node and set it to like the same scale, but let's position those in a different spot. So let's position this at -1, 0, 0, and let's position this at +1, 0, 0. Right? And let's maybe connect another GGL PBR here. So now they're both controlled by the parent anim node, while also using the transformation from the children. So they both have their own scale, they both have their own position, but if we're going to change the position of the parent, then we're going to change the position of both of those. This is very useful in case we want to have a conglomerate of objects which should always maintain the same relationship to each other, but should also still move around in the world. So for example, we can rotate them, and we can, of course, also set a different rotation for each of those. So, for example, this child here could have a rotate x, y, z of, I don't know, 45, 0, 0. We could make it a bit flatter, maybe that as well, and set rotate x, y, x, y, z here, -45. I don't know, just creating something that could look interesting. Let's make those two a bit closer, so -0.5, 0.5 years, basically attach them together. And we could use this system to build, I don't know, some sort of a spaceship or something, a little rocket. Yeah, let's maybe try to build a little rocket, very simple one, so we can make this not a cylinder, but a cone, and we can set this on top of the cube, so make like rocket shape. Let's make it white, and let's not rotate it, right? Let's not rotate that as well. And let's not scale this one. This should just have a scale of 0.5 or actually something like 0.2 or so. And what we want to do is to set it on top of the cube. So let's set position to 0. And I guess now we should rotate x, y, z of 90, 0, 0. Let's first stop rotating here. Let's rotate these 90 degrees on the z-axis. This should actually be -90 degrees. Position here should be 0. And position here should be like 0.5. Bit more, 0.7, not too much, 0.6 I guess. Yeah, cool. So now we got our little rocket thingy, which we can move around using our parent anim node. And we can rotate it. I guess it's more like an arrow than a rocket, but yeah, you get the idea. So this is basically how the jit.anim node works. It has a bunch of cool attributes, and there is one in particular that I want to show you. But in order to do that, we need to use jit.anim.drive. So jit.anim.drive doesn't work like anim node because it is for animating during time. Okay, we used it actually already in the previous video when we were animating the camera, video number 7, I believe. So let's get the grid shape and let's get this anim drive and let's get a PBR attached to this shape. That's a cone. Let's make it a sphere, actually. And this object, yeah, we can use to animate this sphere during time. So let's actually scale this sphere a bit, 0.5. Right. So what does this mean? It means that we can send a message move to anim drive, like 0.100, and at each frame, the sphere will move 0.1 unit to the right. Or if we set it -0.1, this sphere will move to the left. And there is not only move as a message, we can also use the message grow, for example. So in order to reset the animation, we should send the message anim reset to anim drive and to the grid shape, right? So in this way, grow, the shape will just keep growing, minus will keep shrinking, right? There we go. If we want to grow it for each axis at the same value, we should set the same value for all the 3 axes. There we go. And another cool message that we can use is move to. So we can tell it to move to a certain position during a certain amount of time in seconds. So this will be the position, this will be the amount of time in seconds. So move to -200 in 10 seconds, and then it will do it, which is pretty cool. Another really cool feature of jit.anim.drive is that you can control the shapes using our mouse and keyboard. So in order to do that, we need to set the UI listen attribute to 1. And now we can move the shape using our keyboard. So I'm pressing W, A, S, D, Q, Z to move it up and down, back, forward, backward, and whatnot, right? And in order to know which keys are doing what, we can double click on the jit.anim drive, and you will see that it opens this dictionary. This is a max dictionary. And you can see that A moves in the left direction, D moves on the right, and so on. Mouse does this, mouse does that. Now, if we want to change that mapping, we can do it in a couple of ways. One way we can do it is by creating a dictionary. Call it like UI mapping dict or something. Let's give it an embed 1, so it will save the dictionary with the patcher when we save the patcher. Let's copy the content of this dictionary. Let's paste it. So I just copied the content of the default dictionary, pasted in my personal dictionary, and then, I don't know, let's modify it just to check that this works. I will just make this number very big. And then what we want to do is to send this dictionary to the jit.anim drive. Now, there is a UI map attribute. We should be able to use it in a way that we just set the name of this dictionary, and this should work. But I think this doesn't work. So what we need to do is to bang this, and then it will use our custom dictionary. Now, we don't really understand how much this is rotating because this is a sphere, so let's make a cube, and as you can see, it's rotating real fast since we set a value of 10 here. If we set a value of 0.5 here and 0.5 there, close the dictionary, send it again, and whoopsie, just reset the position with anim reset if I don't know anymore where I am. And let's try to rotate it, and now it will rotate really slowly. Okay, so cool. We can modify this dictionary using that this method. Nice. Let's get rid of these, and let's actually connect this anim drive to the parent node, because we can do also that, right? We can now move the parent using our anim drive. So this parent object is getting the transformations from the anim drive, which is now the parent. This is another child. So I guess now you are seeing why we are talking about hierarchical transformations, because we can establish these relationships between the different objects. Jit.anim drive can only be a parent, can never be a child of a jit.anim node. So jit.anim drive will always be on top, let's say. And one thing that we can do, for example, on this jit.anim node is that we can say, look, I don't want to move this arrow or whatever this is on the Z plane. I just want to move it on the X and Y plane. So we can check this attribute lock plane and set it to 3, Z plane. So what happens now is that this will only move on the X and Y plane and not anymore on the Z plane. And this is something that we cannot do from grid shape. We need an anim node for that. So that's a pretty cool feature. Now I cannot, even if I'm pressing the keys to move it on the Z axis, this is only moving on the XY plane. So that's real cool. It's another cool thing that I want to show you. Let's just make this slightly shorter, and so position here 0.4, right. What I want to show you, it's another cool feature, so we can orient this object in a certain direction. So we can get the anim node, the parent one, and there is an attribute called direction. So with the direction attribute, we can set the direction in which the object is oriented. So what will be cool to do will be to set this direction according to the motion. So if the arrow, let's say, is moving in that direction toward right, it should orient toward right. Otherwise, if it's moving up, it should orient toward up, and so on. So in order to do that, we need to do a bit of vector calculus. So what we need to do first is to create another jit.anim node. And we will connect this here. And now we want to get at every frame the position of this anim node. Because if at every frame we get this position, we can calculate a vector, which is the difference between the current position and the position on the previous frame. And this will give us a direction vector, which is the direction in which this object is moving. And we will use that to orient the object. So in order to do that, we can create here a send metro on the JIT world and then a receive metro here, which will give us a bang for each frame rendered by the JIT world. And we can create the message here, get position from this anim node, and this will give us the position of the anim node at each frame, right? Cool. So what we need to do then is to calculate the difference between the current position and the position in the previous frame. So we can go here. First of all, root position. So we will just get a list of 3 number. Then we want to create a trigger, list, and then we want to create a vexp object. So a vexp object performs operations on lists. So we want to do list1 minus list2. So list that comes, list with float numbers that comes from the left inlet minus list with float numbers that comes from the right inlet. And first we want to send out the calculation with the list that was stored in the previous frame. And then we send the current position on the right inlet. So this will be the old position in the next frame. Hopefully it makes sense for you. And what we get out of that, it's a vector that will represent our direction, the direction in which the object is moving. Cool. So what we can do then, I guess, is just to say prepend direction and see if this already works. First of all, let's not scale this object here, right? Let's also actually give it the lock plane, or let's give the lock plane attribute to this node here. So lock plane 3 actually, we don't want to move on the Z axis. So, and it is working in a way, as you can see, is moving. The rotation of the object is correlated with its movement, but it's not correct because it's not rotating toward the direction of the movement. So first of all, let's here reset anim for these 2 objects. This is a bit too far. Let's set it right at minus, maybe just at the center here, or like at -2. We could actually set this position, not here, but again on this object here. Let's maybe set it a bit farther, and let's not reset the anim here, otherwise it will reset also the Z position, which we don't want. So yeah, this is not rotating correctly. So what we can try to do is to set here the rotate X, Y, Z attribute and see, maybe we just need to rotate these 90 degrees. And as you can see, it's strangely rotating it incorrectly because I'm rotating on the Z axis. So this should actually rotate the object in his kind of like in his on his Z axis, but that's not what's happening. So I think a solution could be to put another jit.anim node here in the middle between these 2 and give to that one the direction, right? And let's delete them again so that the hierarchy is kind of created again from scratch. And I think we need to rotate it also here on the x-axis. And I guess this is working. Sometimes we lose the position. We lose the arrow because the position goes too far. So let's set the position here to 0, 0, actually -2. And there we go. This seems to be working. Okay, so yeah, it's a bit tricky, this whole hierarchical stuff. For example, here, why do we need to put a jit.anim node in the middle? Maybe there is a better way of doing this. I could not find one in the time I was making this tutorial. I will do some research on that. But if it works, it works. So we got now our arrow orienting toward the direction of the motion, which is pretty cool. We could use an automatic generator for the movement and still have the arrow orient toward the direction. So yeah, we're going to see that in some future videos. There are some other cool attributes like the tripod attribute, which I think we're going to see in some future video. But as we saw it in the video number 7, this allows the object to not like tilt, always be parallel to the ground, which I'm not sure in which way it will work with our little animation here. If you are curious on what else you can do with the anim system, you should check the help files of the objects, the examples in the max examples folder. There is a bunch of things that we can do with that, with the anim.drive. For example, modifying its speed is actually something pretty important. So if we want to have the objects to go slower, we can then modify the speed. We can modify the ease, which is also a very important attribute, which basically determines how long the object is gonna take to stop and to start when we first press the keys. So basically how much the inertia force is going to affect the movement of the object. If we set it to 0, there is not any inertia, so it's just going to be very fast. The movement is just going to start like super fast and stop super fast. And if we augment this ease, then we get a kind of a smoother feeling to it. Looks like floating in the space more, which could be something that we prefer, depends on what we want to do. So this is it for the 9th video of the Jitter course. I hope it was not too confusing. We are going to see more of the anim stuff in future videos, especially like jit.anim.path. I also have a video on jit.anim.path that you can check. Will be a link in the description or something. I will put it also at the end of this video. And yeah, that's it. If you want to grab this patch, you can grab it from my Patreon. And in this way you can also support the channel, support the creation of this video. That's very much appreciated. If you have any questions, you can also reach out to me via Patreon. And I will see you in the next video. Thanks a lot for following, have fun, and see you soon. Ciao.